Everybody, my name's Anton. I'm working at Canonical as a product manager for MAAS, which is Metal as a Service, which enables really fast server provisioning in an automated programmatic way. So essentially providing an API and abstracting away a metal. So you can treat it just like a cloud and build your own bare metal cloud. Today, we're actually going to set up a virtual environment on a single machine. And we're going to create a whole bunch of VMs that represent bare metal servers. And we're going to get Kubernetes running on that. So in a single server, you'll have MAAS running, LXD, and we're going to use Juju and Ceph together with Kubernetes. So at the end, you end up with a functioning Kubernetes cluster that you can deploy applications to. So we don't always have a whole bunch of bare metal lying around. Maybe you just have a single spare machine, and providing that machine is powerful enough, you can actually do this entire thing on that machine. So although it's not truly bare metal Kubernetes, the concept is the same. And we're going to show how it can be done while showcasing the different canonical products, Juju, MAAS, LXD, and also using Ceph and Kubernetes, as I mentioned. You'll need a decent machine with a recent version of Ubuntu, and preferably the machine is freshly installed so that there's nothing there that might get in the way of doing this tutorial. You'll need KVM extensions working, 32 gigs of RAM, and about 500 gigs of free disk space, and a good CPU. 4 cores or more will be ideal. There's a repository for this tutorial. It is at GitHub under Anton Gisli /MAAS bare metal Kate's tutorial, and we're going to be working through that today. So what you'll end up with is this gray box, and inside the box we have some pretend bare metal machines, metal 1, 2, and 3. These are VMs using LXD. We'll have a LXD bridge, which allows us to have a virtual network in essence so that we don't interfere with your home network or your lab network. We'll have a Juju controller. We'll have a network here, 10.10.10.0/24. We'll have Juju and MAAS there. And using Linux tools, we'll set up source net and routing so that we're able to access the outside world from these virtual machines. I was going to do this in 2 videos, but I've decided to do it in a single one. So what we're going to do is install LXD and configure it, configure networking and persist that configuration, install MAAS, configure MAAS, and add LXD to MAAS so MAAS can control LXD. And then we're going to create some VMs in LXD using MAAS. And after that, we'll use Juju. So we'll set up Juju. We'll add the MAAS as a cloud to Juju. And then we're going to deploy Kubernetes and Ceph. Let's get started. Okay, so the first thing we need to do is SSH onto our machine. In my case, it is at this address. And we need to clone the repo to make life easy for ourselves so that we don't have to type everything out. So just grab the address there and clone it like so. And so now we should have everything in this directory, all the files that we need. So now if we have a look at maassetup.sh, we can get started. So we don't have to type all of these things out. We can just grab them and paste them in. So if we grab lines 2 to 6, that will install LXD, latest version, because LXD normally ships with Ubuntu, but we need to update it to the latest version. We're going to use JQ later on for parsing some output from some of our commands. And of course the MAAS setup. So let's just paste that in. And we have already cloned the repo. So what we'll do when that's finished is we need to get some information about the network on your host. We need to know which interface is the exit interface for your default traffic. So we'll just use a little bit of trickery here, some scripting to figure out which interface that is. Basically what we're going to do is look at the default route and check which interface it is and then store those in some environment variables. So let's grab those. All right, it's finished installing. So we should just check those variables like this. So it found the interface, which is ENP6S0. And also, if we grab for that, we have our IP address. And if we look at our IP address, indeed it is 200.15. And if we look at the route, IP route, we see the default is from that network, and with that interface, so this is correct. We need to enable IPv forwarding because we're going to be doing routing for our virtual network. So that is now active. And this is the source NAT with IP tables. So we're going to use those variables that we got before. If we can check the NAT table, and there you see we have the rule for source NAT. So that's the networking finished. Now to persist it, we just grabbed lines 20 to 22, sorry. We're going to use a package which will persist everything for us and ensure that every time the computer starts, it'll have that NAT configuration present. Okay, that's done. So now we can initialize LXD. Now, before that, let's just take a peek at the LXD configuration. The important things here are the network. That's the network we saw before, 10.10.10.1/24. And the bridge name, LXD BR0, the storage 500 here, and also the interface names. There's also a password specified here. This is not a production system, and you should change this if you are going to do anything remotely near production. But for today, it's fine. That password we're going to use later when we configure MAAS. So let's just initialize LXD. Take a few seconds. And let's verify the bridge is there, and it is, and we see also that it has the IP address that we expect. So that IP address, you will actually see, if we do IP ADDR here, you can see that that IP address is now configured on that bridge, and it's LXD that has made that happen. This command just waits until LXD is ready, which it is. So now we can initialize MAAS. This is telling MAAS where the database is, which is on the local host, and also what the URL is for MAAS, which is based off the IP address that we figured out earlier. So that takes a little while. While we're waiting for it, we can talk about the next commands. So in order to interact with MAAS, we need to have a credential. And we get the credential by running a command with sudo. So it's a security thing. First, we create a user called admin, and then after that, we're going to get the credential for that user. So we run it like this, create admin, and now we can export the API key. Before we do that, we can... Don't worry, my MAAS server is not publicly available, and it will be destroyed afterwards. So you can see here the API key is now stored in our environment variable. And we can log in. So using the API key that we got, and now not running this as the super user, you can see we'll be able to log in because we have the credential. So you see we're now logged in at the MAAS server. Now we need to configure MAAS's knowledge about networking. We're going to create a subnet and configure VLAN tags in primary rack. Now we're not actually using any VLANs, it's just every single network or subnet in MAAS has a concept of VLAN and fabric, even though they are just defaults, and there are IDs associated with those. So we should have all of these now in environment variables, and we should just quickly check those. And you see here they all are. Fabric ID 1, VLAN tag 0, and primary rack ID. Now this is actually a machine identifier. MAAS, everything in MAAS, like this, is modeled similar to machines, including the rack controller. And if you want to learn more about what region and rack controllers are, you can read about that on the MAAS website. So now we have that information and variables, we can run these commands to actually do stuff. And the first one we have here on 42 is to set a default gateway for the subnet. So we know that the gateway is 10.10.10.1. That's the IP address that is on the LXD bridge. So that has succeeded. Now we will do some DHCP configuration and turn DHCP on in line 44. And then line 45, we're setting a DNS server as well. So we can just run all of those together. There we go. So we have networking now. We have MAAS installed and running. now we can move on to configuring and machines and telling MAAS about our LXD setup. First thing we're going to do is create a VM host in MAAS, which is referencing LXD. So here you see the password we mentioned earlier, and we also see the address, which is this machine on port 8443, and the project is MAAS. And at the same time, we're going to grab the ID of that VM host. So MAAS models LXD as a VM host, so it needs an ID as well. And we can actually check the ID, and it is 1 because this is a fresh machine. If you had more, then this would increment. We're going to want to assign all of our CPUs to all of our machines. And to do that, we need to have some oversubscription or overcommit ratio. So we have 8 real cores in this machine, 16 hyperthreading. With this, we will now have 64. And that means we can tell all of our VMs that they can have up to 8 cores. That's just so that if one VM is not very busy, then the other ones can always access all of the horsepower available. Now we're going to create some tags. We're going to use tags with Juju later. The way that they work is that we can tell MAAS to assign tags of a certain type to machines. So when we create a virtual machine later, we might want to say, okay, this one is for our Juju controller, and the others are for our bare metal machines. I will run those 2 commands. And here you can see they both succeeded, right? So we have a tag called metal, and we have a tag called Juju controller. At the moment, that doesn't do anything, but MAAS just has those tags now installed. And now we can create some machines. There will be virtual machines, and the first one we can do is the Juju controller. So we run this command here, grab the whole thing off 60 and 61, and what it's going to do is create the machine with 8 cores, 2 gigs of memory, architecture AMD 64, and configure storage with 16 gigs. And the host name will be Juju controller. That's not the tag, that's the host name for this machine. So here you see the system ID that uniquely identifies this machine. And now the next set of commands is going to grab this system ID for us automatically, so we don't have to do any copy or pasting, store it in this environment variable Juju system ID, and then we can run this command on 66, MAAS admin tag update nodes, add the tag Juju controller to the machine with the system ID. And you'll see that that succeeded. Now, time to build our 3 bare metal machines and also tag them with metal. So I've just made a little for loop here. It's going to compose 3 machines with 8 cores, 8 gigs of memory, AMD 64 again, and storage is a little bit different because one of them will be for the OS, or one device will be for Ceph. So 25 gigs and 150 gigs. And the hostname will be metal123. We'll also grab the system ID as we do it, and then we'll tag them with the tag metal. So just grab that. Now again, the tags are going to be used later when we use Juju. So when Juju works with MAAS as a metal cloud, you can specify constraints like, I want this to be deployed to machines with tag metal, or I want this to go to machines with tag Juju controller. Juju can also tell MAAS to create more machines, but we're not doing that today. Okay, so before we move on to the Juju part, let's just have a look at our MAAS installation. You can go to your browser and go to the IP address of your machine, which I just briefly forgot. It's .15 on port 5240, and you will have a fresh login page here. And the username and password is admin. So the first thing you'll see when you log in is this. You see the DNS that we configured. That's good, so we can just continue. You see the images that is syncing. Can just continue again. Now you see MAAS has been set up. But there's one more thing we want to do, which is to put our SSH key into MAAS. So you go back to your terminal and run SSH keygen and just accept the defaults. Now, if you've already got a key called IDRSA, just be careful, you might want to use a different name, but I will use the default. And if we grab now .pub like this, just grab that whole key and copy it. And now go back to your browser, go to upload, paste in the key, import, and then finish setup. This means that MAAS knows the public key that you gave it, and it's going to install it on every machine that it sets up, meaning that you'll be able to SSH into any of those machines using your private key that you have. So if we go to admin and then SSH keys, you can see here the key is registered. Let's also go to our KVM tab here. And this is where you can actually see that we have the VM host that we added before. And we can see the RAM allocation, we can see the core allocation, and the storage, which is a little bit oversubscribed, but I don't think that's going to cause us any problems today. So if you click on this, you'll see more detail, and you'll actually see the different machines that we added in the CLI. It's still working. It's commissioning them. And when it's finished commissioning them, which means testing them and gathering information about them and storing it in its database, you can deploy them. You can also see it by clicking on machines here, and you'll see that these 3 are completed, and it's turning them off live while we're watching because it's finished commissioning them. We can watch this one, Metal 3, as it does this, and it will turn off in a second. And now it's finished. That's good. Okay, so MAAS is all set up. It's got our SSH key in it. Anything we do with these machines, if we deploy them, it will be accessible by us. Now, just another thing, if you were going to do something manually with them, you just click the machine like these 2, select Metal 1 and 2, and say, click take action, deploy, and then you would be able to deploy Ubuntu to these 2 machines with just a few clicks. I'm not going to do that now because we're going to use Juju for this. So let's install Juju first. So just these 2 commands here. You don't need to be in your home directory to install Juju, of course, but we're going to need to be there for some of the later commands. Okay, we also need to do a little bit of editing on our MAAS cloud configuration. So let's go back actually and take a look at that. So look at maascloud.yaml. It's a very basic configuration that we can use for configuring Juju. I've got a placeholder in here for the IP address because you don't know what it is until you know what it is. So we know what it is now, and it's in our environment variable IP address. So we just use sed to, and that will work. We should go back one. And now you can paste this command. And let's just verify that that worked correctly. And now you can see our IP address has been put in there, which is great. Okay, so the next command is add MAAS as a cloud using the configuration file that we just fixed. So it's Juju add cloud, local, MAAS cloud, and then the name of the configuration file. Okay, so that's done, but now we need some credentials for this cloud. We need that API key that we were using before, because just like us, Juju needs to log into the machine. So you might recall that we had it in an environment variable. So you can actually just do this and pipe it to grep and search for API, copy this key, or first we're going to run this one, add credential. Okay, and I'm going to call it MAAS creds and just hit enter here. And now here's where you grab your key again. Sorry, I grabbed it a little bit too early. Just grab that, paste it in. It won't show anything, and be careful not to push space before or after you paste it. And also don't grab any extra characters on either side of your key. But paste it in here and push enter. And now you'll see that it's been added, the credentials. So let's take a look at Juju Cloud's local. And we can see our MAAS cloud, as well as it's recognized that we have LXD on the local machine, but we're not interested in that right now. So MAAS cloud is there. And we can also run Juju credentials. And you'll see we have the MAAS creds for the cloud MAAS cloud. So Juju is basically set up to interact with MAAS now. The next thing we need to do is bootstrap Juju in the MAAS cloud. So this command 89 does that. It's going to try to install a controller inside a machine in MAAS, except that I've added a constraint using the tags that I mentioned before with the Juju controller tag, and also memory of only 2 GB, just to try to save a bit of RAM for our other machines. So if you run that command, it will start doing its thing. And interestingly enough, you can go back to the MAAS, your MAAS browser, and you'll see that Juju, the machine Juju controller, which had a tag on it, is deploying now. So Juju has caused it to start deploying, which is exactly what we wanted. And that was based off the constraints that we gave it. So that'll take a little while. While we're waiting for it, we can do something else that we're going to need to do. So Juju has a dashboard, but it only exposes itself locally on the controller. So we need to SSH to that. First, let's just jump over to our machine again. And if you run something like Juju GUI, it's not going to do anything because the controller is not ready, because as it notes here, is bootstrap still in progress. But it's going to run on a local port on that Juju controller machine. And in order to get access to it, we will need to see it, or we will see it here as an IP address on this Proud Possum machine, which is our host. So when we SSH to it, we're going to do some port forwarding. So we can do that with -l and then grab a local port that you know is free, like 8080, for example. And then the IP address of the controller host, which we can actually just quickly check here, is 10.10.10.2. So it's showing in MAAS that the Juju controller machine has that IP address. And we will forward it to some port that we know Juju is running on, or the Juju dashboard. Now, it's going to tell us when it's finished, which takes a little while. So we'll just wait for that, and I'll be back in a minute. Okay, so we're back. Juju's done its thing, and we have a controller installed. You can see here the process went on for a little while, but now it's completed, and the MAAS Cloud default is now available. And we can take a look by going Juju controllers and Juju models. And so you see that is there, and just recently as well. So that's great. Now if we run Juju GUI, now we see the port. And so this is how you would try to reach this. Now I'm not sitting directly on the Proud Possum machine, and that's why I need to SSH to it and do some port forwarding. So I will remember this port, 17070, and I just put it here on the end. Now, if you're not familiar with SSH port forwarding, it's fairly simple. It just opens a socket on my local machine, and it will forward it over SSH and point it at the remote, or try to reach 10.10.10.2 through the tunnel that goes to 200.15. So if we run that like this, it worked. It will also drop you into a shell on that machine. And now I should be able to browse to my local host on port 8080. So just type https localhost 8080 and hit enter. And it will throw a security risk because it's a self-signed certificate. Just click advanced. If you're in Firefox, accept the risk and continue. And for some reason that is not working. Because I need to put /dashboard. So don't forget /dashboard like that. Okay, so it's admin, and then grab the password that Juju gave you when you ran Juju GUI and paste that and log in. So now you can see in a little overview of what's happening in Juju. And if you click on the default controller, you see there's nothing there right now. So that's to be expected because we haven't tried to deploy anything. So what happens now is that we need to tell Juju that it wants or needs some machines. So if you run Juju machines, you'll see that there's actually nothing there. But we know that we have the 3 metal machines and the controller in MAAS. So if we would run Juju add machine 3 times, we will end up with Juju claiming 3 machines from MAAS. So here I just run it once and it's created machine 0. And if I run Juju machines again, you can see it's starting to work with that machine. And if we go back to MAAS, you can see that that machine is now being deployed. And if I do it again, it will grab another one. Juju add machine. We should see a live update on the right-hand window. There we go. So it has started on the second one, and if I run it again, it'll add another one. It'll claim the other one. Now, if you keep running this, you'll end up with it trying to use LXD to create more until you run out of resources. So I'm not going to do that. I only want to have these 3 machines, and we can see them here. Each one has an ID, and these IDs increment with each machine that you add. They don't go backwards. So if you delete these machines and then create new ones, they will have different IDs. Just something to keep in mind. Now, let's move on to actually deploying something. We'll just have to wait for a little while. Again, we need to wait until those machines are ready. So we'll be back in a minute. Hey, welcome back. So let's see if these machines are finished deploying it. And yes, they are. So that's great. And you'll see that they are now all on in MAAS, and they're all deployed with Ubuntu 20.04, which is great. So now that they are done, we can actually deploy something to them. So first thing is Ceph. We need some storage to give to our Kubernetes cluster. I know there are easier ways to do this, but I wanted to show you this because this is quite neat. Both to try to play with Ceph in a basic way, but also how to install things. So this is deploying Ceph to a bare metal cloud. So assuming that you already had MAAS set up and you had a whole bunch of machines, then to deploy something like this is as simple as these commands. So on 114, line 114, we have Juju deploy cephmon 3 instances. And here is a clever command which says, because I wanted to conserve memory space, I thought that Ceph monitoring can actually be deployed as containers. So LXD also supports containers. So here it's actually going to use LXD on machine 0, 1, and 2. And those are the machine identifiers 0, 1, 2, right? So let's grab those and deploy cephmon. Okay, so it fetches a charm from Charm Hub and then starts to deploy it. So it's just like magic. And if we run Juju status, you will see some magical things like the Ceph units. And you can read about Juju in more detail on the Juju homepage. But also importantly, status, you see it says waiting, scale 0 of 3, versions, and so forth. It also says it's waiting for machine. And the reason is because if you look down here on machine 0, 1, and 2, it's actually working with LXD right now to create those machines that it needs. And here you can see it's in progress, right? You can also go to now back to your Juju UI that we had open before. And you can see the application we deployed. cephmon is here in status waiting. And you can click on that and you can see a bit more detail. So it's similar to the status command that we were using before. So it's still allocating the machines. Okay, so the containers are started. And pretty soon this should flip over and it will be kind of happy. It won't be really fully happy because this is only cephmon, it's not everything that is needed. What we can do while we're waiting is we can also deploy Ceph OSD to the actual LXD bare metal machines that we have created before. So you notice that this is a little bit different than the first command. There it had LXD, which was specifying do this in a container, whereas this is specifying do this directly on the machine. So we can run that in parallel. And the machine will get quite busy now. So you can see it's doing a lot of things. You can see here cephmon, and we can see Ceph OSD, and they're in status maintenance right now. That's because they're still installing. And if you like, you can just run a command like line 121, but first let's relate these. So Ceph monitor needs to monitor something. So with this simple command in Juju, we relate these two deployments together. So you can see in status that if we didn't do that relationship, then after a while, they would both complain that they're missing something because they won't work unless they have this relationship in place. Now you can use this watch-c Juju status -- color to watch this in real time. It can be quite interesting to see what's happening. It changes constantly as different pieces are being deployed. And let's just wait for a bit and I'll be back in a sec. We're back. And here we can see that it's finished, which is great. So the status is active for both Ceph Mon and OSD. And by the way, if you don't know what Ceph is, you can read up on it. And we also have a lot of documentation about it at Canonical. So everything is looking just fantastic right now. So you can Control-C to get out of this watch command. And now we're going to deploy Kubernetes. So we do that simply with Juju deploy Kubernetes core. We're not going to use charmed Kubernetes today. This is like a smaller deployment type of Kubernetes with just one worker and master. And we're going to say that we want it mapped to the machines 0 and 1. So grab that and run this. Now there are a lot of components for Kubernetes. So it's going to be, and again, it's going to be a little bit of a wait. A lot of people call this settling, wait for it to settle. So the deployment here is completed, but Juju and the machines are going to be busy for a while. So if you run the watch command again, you'll see all the new things for Kubernetes, and you can see that it's installing. And let's just make this bigger for a minute. Okay, so installing Charm software, agent initializing. Here's our Kubernetes master, Kubernetes worker, a flannel for networking, etcd, EasyRSA, and containerd. And they will take quite some time depending on how powerful your machine is. In the case of EasyRSA, it is actually using a container. You see that because it says 0/lexd/1. The other ones are all going directly to machines. And since we specified machine 0 and 1, you'll see that the Kubernetes master and all of its friends are on machine 0, and the Kubernetes worker is on machine 1. And it's normal to see these statuses changing over time because these are internal things that need to be set up before the Kubernetes deployment is said to be deployed. So as things are installing and changing, then there will be different statuses and different things that are broken. And this is what the settling process is all about. Again, it's quite interesting to watch this. You might like to have a coffee while you do it. Let's just leave it going and I'll be back in a minute. All right, back again. And we can see here that our Kubernetes cluster has finished settling, which is neat. So we have all the different components now. We have Ceph here, and we have Kubernetes and its individual bits and pieces all happy and working and ready. So we can push Control-C here, and can also be interesting just to run top. Let's have a look at how busy our machine is running all of these bare metal machines. And we can see that it is fairly busy actually, doing something. Not entirely sure, but it's still usable, which is a good thing. So this machine, I should mention, has 8 cores and 32 gigs of RAM, and it is a AMD Ryzen 1700. Okay, so let's now move on to using our Kubernetes cluster. So one thing we can do is actually grab some credentials for our cluster. So we just create a directory here and then run this command, juju scp, which is going to copy the Kubernetes config for us. And if this doesn't work, then just try with master 0, like so. Okay, so now in here, you should see a config file. And if we cat that out, we'll see a certificate. Again, this is not a production system, so it's okay. I will be blowing this away when I'm finished the tutorial. But we can see a cluster, which is great. So now let's relate our new cluster with Ceph. So this is essentially telling the two about each other. And this is how Kubernetes will gain access to storage. So after you've run these two relation commands, you can run Juju status again. And let's just blow that up a little bit. You can see that there's some activity here. And this is most likely the actions that are being taken behind the scenes to connect them together. And if you like, you can run your watch command again. Just push Ctrl-R and start typing watch, and you can get it back like that. And we can sit here and check this until it's finished, and I'll be back when it's done. So our Kubernetes cluster should be settled by now, and we can see that just run Juju status again, and you'll see whether everything is active and idle. So it's time to register our Kubernetes cluster with Juju. So run Juju add k8s my k8s. In my case, I need to use update k8s. That's because I have previously been through this process, but for you it is add k8s. And then Juju bootstrap my k8s, like so. And this will take a minute, so we'll be back in just a second. So now that we've bootstrapped our controller, all we need to do is start deploying stuff. Okay, so first Juju add model hello-kubecon. And how that works is it basically creates a namespace inside Kubernetes. And we can just quickly take a look at that. So Kubernetes get namespaces. And there you'll see there's a hello-kubecon namespace that's been set up. And we can deploy hello-kubecon just like this. And don't worry about the configuration thing. There's a bug in that charm, so we'll just ignore it. The hostname is going to end up being hello-kubecon for us, for our ingress. And now we can deploy an ingress, Nginx ingress integrator. This is a charm that sits in the cluster and basically will set up ingresses for us when we relate applications to it. But in order to do so, it needs to have credentials. So we run Juju trust, which gives it the credentials for the Kubernetes cluster. And now when we run this Juju relate, it's going to set up the ingress. Now, if I first get ingress on the namespace hello-kubecon, like so, there are no ingresses. But the moment I run this relate command, you'll see soon that there is one. Let's check Juju status. And you can see that it's executing. So eventually there will be an ingress in place, and there you can see it. So that's pretty neat. Setting up ingresses is not trivial. If we describe the ingress, you'll see what it looks like. If you do this, you'll normally use tools like Helm or do it by hand or something similar. It's not usually so easy, it's quite error prone. So this is very nice that Juju did this for us. And here we can see the host name, and we can see the backends. In this case, it's the service, this Kubernetes service. And if we describe that service, we're going to see that it's a cluster IP. That's the IP on it. And then it's going to the target port 8080, and the endpoints are here, which is where the actual containers are running. And if we get the pods for hello-kubecon, like so, then you can see hello-kubecon 0 is sitting right there. It won't work right now from my desktop machine or yours, because we need to do some port forwarding. So there's this IP tables rule in the NAT, in the pre-routing, that is going to grab any traffic that comes in on the host interface and redirect it to destination port 8000 to the machine, the node, where everything is, where the ingress is located. So just run that and then verify that it's there. IP tables -tnat-nl, and there you have it. So now we should be able to access it from outside. We should also check that the ingress is actually running on 10.10.10.5, which is a very important part of it. And we'll do that in a sec. So the way to verify where the ingresses are is to run this command kubectl get ingress. And you'll see here that actually there's two. This is because of some work that I did previously, but if you're running this from scratch, you should see only one IP address here. And in that case, you see it is 10.10.10.5. So at this point, we should be able to access that ingress from outside. So first, a good way to test that is with telnet. So we can telnet to the IP address of my host machine on port 8000, and you see we have a response. And then if you edit your host file, you just need to specify the IP address of your host and add hello-kubecon here as the host name. Right, so if I now do ns lookup on that, I'll get something like this with the IP address. And now I should be able to go to my browser, go to hello-kubecon on port 8000, and you have a working application. So this means that everything is working end-to-end, the IP tables is working, Kubernetes is up, the hello-kubecon is deployed, there's a working ingress. Let's take a look at the next steps. There's some extra bonus material that I thought we could do, which is pretty cool. I wanted to show you how to scale up and down your cluster as well as your application. So first, let's switch ourselves back to the MAAS cloud and run our status just to take a look. Okay, so we've got a Kubernetes worker here, 0, and a Kubernetes master, 0, and they're on machine 0 and 1. But what about machine 2? Machine 2 could actually host another worker, I think, for Kubernetes. So the way that we do that is we run juju add unit Kubernetes worker --2 2, and that's going to set up another worker that is going to join the cluster. And you see in this case it will call it Kubernetes worker number 3. That's because I've previously been adding and removing them while testing this. And we can also see the IP address, which is 10.10.10.4, and you remember that we saw that in the ingress like so. This is set up automatically for us when you add that new worker. And when we add the hello-kubecon, when we add another, when we tell it that we want to have more than one, and it spreads itself across the nodes in the cluster, it's automatically changing the ingress or making sure that there are multiple addresses representing the metal machines, because that's where the traffic has to come in. So that's very neat. Right, so it would have taken a little while to add the new worker. So let's just quickly go down and check that so I know where I am. Make sure you run Juju status and just check that it successfully added the new worker. Now we can see it here. Kubernetes worker 3 is now active and idle and is on machine 2, which is really good. So now let's add, now that we have a new Kubernetes worker, let's switch to our Kubernetes cluster, and then let's add a unit. So it's just juju add unit -n1. That's how many you want to add of hello-kubecon. Right, so we run that and then run Juju status. You will see that now there's the current state and the desired state in terms of the number of these that we want, of these units. It will take a little while, but not too long because it's a container. And you see that the ingress was busy there for a second, and that's because it's just checking that there's an ingress, that the ingress is set up and available on every node that this application is running on. What this means is, this is very important, but this that you can hit either of the nodes and you will be able to reach the destination. So we can play with it actually. So if we go back and grab our IP tables rule and add a new one, but point it at 10.10.10.4 in my case, and I'll add a new port here, 8001, and add that, and then just verify it sudo IP tables -tnat-nl. Now I've got two rules, so I can hit either 8000 or 8001, and it's going to send me to either the new Kubernetes node worker, which was 10.10.10.4. Okay, I hope I'm not losing you here, but let's like edit the hosts. It's still 192.168.200.16, which is fine, so you don't actually have to edit that. What we do is we go to a different port. So we grab that and then paste it here, and it is 8001, like that. And this will go to a different server, and they both will work, even though we're sending it to two different nodes, right? So 8000 represents one of the Kubernetes workers, and 8001 represents the other one. So it's very neat. Now we have a very resilient setup. Okay, so if you wanted to know how to do load balancing, then I'm going to leave that up to you. You can Google for IP tables round robin. So instead of these two different rules that I've got, it's not really that useful. What you'd rather have is just that it will automatically send it to either one of those nodes. You can check out Metal LB, which is part of the Kubernetes projects, I believe. Or you can do something simple, like a very simple IP tables round robin port forwarding. Okay, so now let's scale down. We're going to do everything in reverse. So first we're going to remove the unit. I'm on the wrong machine. And if you run Juju status, you will see that now there's 2, but we want 1. So it will take a little while. And eventually one of these will disappear. Okay, so mine has disappeared. And hopefully yours too. So now I only have 1. And now we want to remove that Kubernetes worker that we added. So we switch back to the MAAS cloud. And then unlike Kubernetes, in this case, we just remove the unit by name. And this won't work because there is no Kubernetes worker called number 1, but there is one called number 3. Just delete that one, and then you will have to wait for the cluster to do the work or resettle. Now, it might seem trivial, but it's not. It's really, really cool that Juju is able to do this, to simply add and remove Kubernetes workers with very simple commands, or via API for that matter. And together with MAAS to be able to reserve bare metal machines behind the scenes. Now in this case, I've been forcing everything onto 3 fake bare metal machines, but in a real setup, this would work just fine if you had all of the real metal machines actually deployed and managed by MAAS. Now you could wait for that to settle, but it doesn't prevent you from actually moving on and cleaning up. So if you want to clean up, I'll just show you a couple of quick commands. So let's check which controller we're on. Okay, I need to switch to my Kates here. And then let's say I just want to delete the model. So I want to remove my application. So that's quite simple. Just destroy model, hello-kubecon, release storage. And that's going to get rid of the model. It'll take a little while. If you push Control-C at this point in time, it'll just let you out of the Juju CLI, but you'll notice that it says the destroy model is still running in the background. So that's great because you can jump back to your CLI like that. Then if you decide, you know what, I really don't want the controller either for Kubernetes in the cluster, then you can run Juju destroy controller and then the name. And it says it's going to include all machines, applications, data, or other resources. So let's say yes. And it's going to be waiting probably for the model of the hello-kubecon, which we're still cleaning up. In addition, if you want to clean up the Kubernetes cluster itself, I haven't got the commands here, but I'll just tell you. You change back to the MAAS controller, and then you basically destroy all of the applications that you deployed for Kubernetes, and that will clean up everything there running on the bare metal. And if you want to go even further than that, then what you do is you go into MAAS and you just find the machines. You can just completely blow them away with a few clicks, which is quite nice. And if you also want to clean up all the networking configuration that we've done, then just go back and use IP tables to remove the rules and then run that package installation thing again. The package installation that persists the IP tables, so that way it will clean everything up. Hopefully you've done this on a fresh machine anyway, so you don't have too much cleanup to do, or a separate machine at least. And here you see that we have no selected controllers because I destroyed the Kubernetes controller. So if I switch to MAAS Cloud, switch MAAS Cloud default like this, and Juju status, you'll see we've still got all of our cluster and Ceph and everything running there. And if you want to destroy these, then you can actually delete the application. So you run something like Juju remove application, and then start removing these. Okay, so let's recap. We have gone through a lot in this video, but I hope that you've managed to understand everything. I hope it also hasn't been a bit too slow for you, but I want to be sure that it's easy to understand. We've learned how to use Juju, we've learned about Kubernetes, we've learned about MAAS, we've learned about LXD, and we've successfully built an entire setup on top of a single machine. I hope you've had as much fun watching this as I had making this video. This was my journey to learn about MAAS and Juju, etc. And I've certainly had tons of fun. I hope that you will use this or put this to good use. I'd also love feedback. You can contact me at anton.smith@canonical.com, or you can add me on LinkedIn, which would be fantastic. So with that, good luck with your adventures, and I hope you continue playing with these fantastic tools.